Alright, we are going to do something that you have never done before. This is going to be a new thing. We're going to write an arithmetic sequence, which is just a start and a rule, right? And it tells you the difference between the consecutive terms is always the difference written as D, and is called a common difference. So we're talking about something that is a common difference. Alright? And an arithmetic sequence can be described in two ways, explicit and recursive. Alright? As you saw, either an explicit or recursive rule, the nth term arithmetic sequence is defined as a function of n. In a recursive rule for a sequence, the first term, so let's underline recursive rule, the first term is given, and the nth term is defined relating to the previous term. An arithmetic system sequence can be defined using either a recursive or an explicit rule. I can pretty much guarantee you guys haven't done recursive, so that will be the hardest part. So this says write a recursive and an explicit. Alright. So if you look at this, what you need is a common difference. And this one's done for you. Right? Recursive rule requires a start. So recursive rule, you're going to have to give the first one. So recursive rule, you're looking for a start. I'm just going to write start. And they're going to be looking for a rule and the difference. And to get a difference, you can take any number like 2,500 and subtract the number in front of it like 2,000 for our rule. So we can see this recursive rule, you have a start and you write that. The first term is 2,000. And then you say to find any term, you take the term in front of it and add my rule. And then define for the terms. Alright? And then for an explicit rule, you still need a start, but you just list it, right? And this is the rule right here. You list your start, F1, right? And then you say the difference times the number is equal to your rule. And that's all you really do, right? So we can see our start and our difference times the number minus 1. That's what we do every single time. And we're going to talk about this a lot more in class, right? If I plug in a 1, I want it to not add that 500 because I want that to be my turn. And let's just go through. We will review this a lot when I can talk to you. Alright, and we'll try to get a feel for it right now. So we're going to write a recursive. Remember, recursive is just start and rule. And our rule is going to be defined as the difference. And if we can list that, we're okay. So first thing I do is I find my first term, my start. Well, my start is 5,000. And I'm going to use that in both the recursive and the explicit. So if you learn something this first time, find your start. And the common difference is, well, I can take any term. I'm going to come out to the fourth term, 8,000, and I'm going to subtract the third term, 7,000. And this is going to give me 1,000. But I could do any 9,000 minus 8,000, 8,000 minus 7,000. I'm going to get the same difference of 1,000. So here's how you write a recursive. You do your start first. F1 is 5,000. And then you always say, to find your term, all right, find the term in front of it, and then you add your rule, 1,000. And then you limit your domain for the next term. So if you start on term 1, you say it only works for term 2 and on, just like that. Alright, now the explicit rule. If we plug stuff in, so let's say I plug in, well, I don't know, let's say I plug in 2. Alright, f of n is 6,000. We can see it, which is 5,000 plus 1,000 one time. If I plug in 3, 7,000, right? We can see it up there, which is 5,000. Ooh, I should put 5,000 plus 1,000 twice, right? Since D is always multiplied by a number equal to the number minus 1, right? Look, this is 2, that's the number minus 1, 1. This is 3, I'm multiplying it by 2. You can generalize the result from the table. F of n is equal to my start of 5,000 plus 1,000 times the number minus 1. And that's how that's done. Alright. We're going to go through and do one more of these. So here we go. Alright. Jerome says that the sequence 8, 27, 64, 125 is not an arithmetic sequence. Is he correct? Well, we can find a common difference. If the difference is the same, it is arithmetic. So let's test it out. let's see, 8 minus 1 equals 7, but 27 minus 8 equals 19. 7 does not equal 19, so it is not arithmetic. The concept of arithmetic is you have a common add rule, and this sure doesn't, does it? Alright? So, an arithmetic sequence has a common difference of 3. If you know the third term of 15, how can you find the fourth term? Well, the fourth term is equal to the third term plus 3. That's 15 plus 3, so the fourth term is equal to 18. It's that simple. If you know the rule, you can always get the next term. Alright? So, your turn. I'm going to do this with you because we really should have another practice. The table shows the number of plates left at a buffet after n hours. Write a recursive rule and explicit. So let's go over here and do recursive. Recursive. I need my common difference. So let's do 141 minus 155. So my difference is negative 14. That's my difference. Alright. Every single time I go down by 14, by 14, by 14. So, my recursive rule requires me to say the first term, which is 155, and then to find the next term, I take the term in front of the next, so n minus 1, and I subtract 14, and there I'm good. Now my explicit is just a simple equation. You say, hey, to find n, you take your start of 155, and then you subtract 14 n minus 1 times. Done. We finished it. Alright, I'm going to end this, and we will continue very soon.